Yeah, good evening, children. Good evening, Srijit.
Good evening, ma'am.
I've shared my screen. Is it visible, Srijit?
Yes, ma'am.
Very good. So in the last class, I think we answered A, B, and C, right? And D and E was given as homework. So let's see the answers to these two questions, D and E. And also, we worked A, B, C only using the long division method in the last class. We did not work it using the prime factorization method. So that also will be a part of the homework. We'll see the answers in the next class. So please complete finding the square root of all these numbers using the prime factorization method. All right. Yeah. Now we'll see the long division method for these two numbers. Yeah. Check your answer. I'll be sharing this on WhatsApp with you. If you're wrong, just identify where you've gone wrong. If you have a doubt, you can ask me. Prime factorization method you will try by yourself. So don't try to write on that now. Check your long division procedure. Okay, so you got 231? Okay. Yeah. Okay. And the square root for the next one? Correct?
Ma'am, can we clear the doubts for this one, ma'am?
Yes, what's your question?
No, ma'am. I'm seeing the picture, so I'm clearing the doubt, ma'am.
Yeah. Let me know when you're done. If you have any questions, you can ask me. I can help you. Finished? Every part of the answer is right, Navneet? Have you written 43 and 461 against the correct numbers? You didn't have time to do the homework? Did you go through the recording? Yeah, the first session you must know. I shared the recording with you.
Ma'am? 11649. Ma'am?
Yes?
Ma'am, can I check the answers for all, ma'am? Can you show, ma'am?
No, only these two questions were given as homework. D, I'll share the, okay, you want the answer images of all the subdivisions for question number 6, is it?
Ma'am, for 7649 for that C question, ma'am.
Yeah.
Yeah, yes.
Take a screenshot.
Okay, ma'am.
Done?
Okay, ma'am. Okay, ma'am. Ma'am, I'm the last sub, ma'am.
This one?
Yes, ma'am. Yes, ma'am.
No. We have lots and squares and square roots. Okay. So let's practice more on this. Finding the square root of a perfect square using the long division method. We'll take some more questions, some more numbers. Yeah. So find the square root of 1,67,281 using the long division method. No, you don't take down all the 4 questions. Write the heading. Write down only the number in A. Work that and then B. Don't take down all the numbers A, B, C, D. Let's do the first one together. So what do we have to do? We'll have to group the digits backwards. Group in pairs from backwards. All right. So 817216. Yeah. 4 4s are 16. 4 4s are 16. What's the remainder? 0. What comes down? 72 comes down. Next what? Double the quotient. Double the quotient. No, it's not 16. Double the quotient meaning 4 into 2, 8. 8. You must write it against this number. You must write it against this number. Now, dash here and a dash here. Whatever digit you place here, the same digit you must be placing here. So, if you use a 1 here, you must use the same thing here, 1. So, it will be 81 into 1, correct? What is 81 into 1? 81. But what's the number we have here? 72. It's less than 81. So, you can't use 1. That's the simplest, that's the smallest, but you can't use that. So, what is smaller than that? 0. 0. 0. So, 0 here, 0 here. And that means 80 into 0 is equal to 0. Correct? So 80 into 0 is 0. Now the remainder is 72. The next pair comes down. Double the quotient. Okay, in the quotient we have 40 into 2, 80. You should write that against this number, 80. Now whatever digit you place here, you must place the same digit here. Okay, now this is the last step. Now the given number is a perfect square. Okay. If it were not a perfect square, the question will be different. They'll say find the square root of, whatever number approximately up to 2 decimal places or approximately up to 3 decimal places. All right. In that case, if you're asked to find the square root approximately up to 2 or 3 decimal places, then that means the given number is not a perfect square. Now here, all these 4 numbers are perfect squares. So in the last step, you must get 7281 exactly. Now this number ends with the digit 1. Yeah, 9 nines are 81. So you should use a 1 here or a 9 or 9. Because 9 into 9 is 81. You'll get 1 in the end. 1 in the units place. 9 nines are 81 will give you 1 here. Or if you use 1 and 1, 1 into 1 is 1. Yeah, so don't try any other digit. Try the digit 1 or 9 because it's the last step. You must exactly get 7281. Yeah, correct. So you can try 9 directly, correct. Because 801 into 1 is 801 itself. So you don't have to, there's nothing to calculate there. Very obvious, 801 into 1 is 801. So you have to use a 9. You'll have to use a 9. Okay. 809 into 9. 9 nines are 81 and 9 eights are 72. So 7281. Remainder is 0. So if the remainder is 0, the given number is a perfect square. The remainder is 0. So the given number is a perfect square. Therefore, square root of 1,67,281 is equal to 409. Complete this. Finish working? The first one? Yeah. Yeah. Go to the next one. See, it's very easy to find the square root of this number. You don't even have to perform the long division method. But since the heading is to find the square root by the long division method, you have to do it. Okay. So, but how do you otherwise guess? So what's the square root of 25? 5. The square root of 25 is 5. And how many zeros? In the end, 4 zeros. So the square root will have half the number of zeros. Okay, so 2 zeros. So the square root of 2,50,000 is 500. 500 into 500 is 2,50,000. Yeah, we're going to do that now. Yeah, listen to me. So you'll have to pair the digits from behind, backwards. 0, 0, 0, 0, 2, 5. So we have 3 pairs exactly. So we'll take the first pair, 25. 5 5s are 25. The remainder is 0. The next pair comes down. The next pair comes down. Double the quotient. 5 into 2, 10. Correct? Whatever digit you place here, you must place the same thing here. So since it's 0, you have to take a 0 here. 0, 0. So 100 into 0 is 0. What's the remainder? 0. The next pair comes down. Double the quotient. What? Double the quotient. What is it? 100. Whatever digit you place here, place the same digit here. So it's 0 again. 1,000 into 0 is 0. And now the remainder is 0. So you see that the square root of 2,50,000 is 500. Done?
Yes, ma'am.
Yeah. We'll go to the next one. Yeah.
Okay, ma'am.
Pair the digits from behind. 0, 0, 0, 1, 9, 8. So 9 into 9 is 81.
70.
Srijit, please participate. Tell me. 9 into 9, 81. What's the remainder? What's the remainder? 17 is the remainder. Next. Bring the next pair down. 0, 1 comes down. Double the quotient. Yeah, whatever digit you place here, you must place the same digit here. So tell me the number. Tell me the digit to be placed here, Srijit.
Ma'am, 9, ma'am. Ma'am,
189, is it? Okay. What's the product? What is 189 into 9? What's the product? So 9 and 9 here. 1701. Remainder 0. Then next pair comes down. Next pair comes down. Next, double the quotient. 198. You must write it beside this. 198. Again, whatever digit you place here, place the same digit here. 0, 0. 1980 into 0 is 0. And now the remainder is 0. We don't have any further pairs, right, to bring it down? Yeah. So the square root of the given number is 990. Completed this one? Srijit?
yes, ma'am.
Okay.
Ma'am,
Yeah. Good evening, Sahasra.
how did you get 189?
Now, since this is your first session, you have to go through the recording. Only then you can catch up with the class.
Okay, ma'am.
Yeah. Yeah, do this and share your answer. Finished? Okay. Let's do together then. One, have you paired the digits correctly from behind? 096000 and 1 stands alone. So 1 into 1, 1. 0. Next pair comes down. Double the quotient.
0, 0.
Whatever digit you place here, place the same digit here. So 0. 20 into 0 is 0.
60.
Remainder is 0. The next pair comes down. Double the quotient. Whenever you double the quotient and write it, you should leave a space for that digit which you're going to write. What? How 3? 0 again. 0 again. Because if you put a 3 here, you'll have to, if you use 3 here, you'll have to use 3 here also. So it will be 203 into 3. It will be 203 into 3. But we have only 60. See, 1 itself will be too much. 1 itself will be 201 into 1 is 201. So you have to go less than 1, which is 0. One itself is too much. 201 into 1. Because if you place 1 here, you must place 1 here also. And you'll have to find this product, 201 into 1, which is 201. But the number we have here is 60. So 1 itself is too much.
200.
So you have to use 0. Use 0. So it is 200 into 0. 200 into 0
0.
is 0, not 200. 0. And what's the remainder? 60 is the remainder. The next pair comes down. Double the quotient. Why are you stuck there? So easy. Now this is the last step. This is the last step. We have, yeah, this is the last step, right? We have no more pairs to get them down. And the number ends with the digit 9, 6009 ends with the digit 9. So it should be 3 into 3, 9, or 7 sevens are 49. Only these two digits can give you 9 in the end, 9 in the ones place. Because the last step, only in the last step you can use this trick. Not in every other step. Only in the last step. So now you have to finish the division. Okay.
6009.
6009 ends with the digit 9. So 3 into 3 gives you 9 in the units place, or 7 into 7, 49 gives you 9 in the units place. So you have to try 3 or 7. So which one gives you this product, 6009? 3. 2003 into 3 is equal to 6009. And the remainder is 0. Therefore, the square root of the given number is 1003. Yeah.
Ma'am, you are in mute, ma'am.
Thank you. Sorry. So I have to repeat what I said. Okay. Thanks, Srijit. Yeah. I was telling you here in this question, we have to find the square root of the given two numbers using the prime factorization method and the long division method. The differences in these two numbers, you can see the decimal point, right? Yeah. So you'll have to find the square root of 75.69. So you need to understand how to handle or how to, what is the procedure to find the square root in the case of a decimal number, a number which has a decimal point in it. Okay. And the second number is also 2.0736. So let's see that. So now what is 75.69 as a fraction? 7,569 by 100, correct? So find the, use this method and factorize 7,569. That is factorize the numerator and factorize the denominator. That's what you see here. Fine. All right. Now 7,569 by 100 is equal to, what is this number? 3 into 3 into 29 into 29. And what is 100? It's 2 into 2 into 5 into 5. Correct? Okay. Now, as you always do, take square root on both the sides. Take square root on both the sides. Correct? Yeah. Now, this is nothing but square root of 75.69 is equal to, from 2 3s, 1 3 comes out of the square root. From 2 29s, 129 out of the square root. In the denominator, from 2 2s, 1 2 out. And from 2 5s, 1 5 out of the square root. So you don't see the square root symbol here because from a pair, we've brought out one number. Correct. So now 3 into 29 is 87. 2 into 5 is 10. 87 by 10 is 8.7. So if you have to find, listen carefully, if you have to find the square root of a decimal number using the prime factorization method, you have to express the decimal number as a fraction. You have to express the decimal number as a fraction. If you have to find the square root of a decimal number using the prime factorization method, you need to express the decimal number as a fraction by shifting the decimal point. So you know how to write the decimal number as a fraction, right? Then find the prime factors of the numerator and the denominator. Then after that, write down this fraction, So this number can be expressed like this. That is 7,569 is equal to 3 into 3 into 29 into 29. 100 is equal to 2 into 2 into 5 into 5. Now take square root on both the sides. Correct? That's the next step. I've told you, repeat the step and take square root on both the sides. Then this will come as it is. But what is this number actually? What is this fraction actually? It's 75.69. So put it back. That's the question, right? That was a number given. So we'll put it back. So instead of this fraction, we'll put back the given number, 75.69. So square root of 75.69 is equal to, from 2 3s, 1 3 out, 2 29s, 1 29 out, 1 2 out, 1 5 out. The product here is 87. The product here is 10. 87 by 10 is 8.7. Now we'll see how to find the square root using the long division method. 75.69. So here there is a difference in pairing the digits. Now, okay. There's a difference in pairing the digits. I'll just take a different number to explain. Now, supposing we have 3761.2.79137, like this. So now we have two parts in this number. What we're going to understand, what we're going to see now is how to pair the digits to find its square root, to find the square root of the number by the long division method. How to pair the digits. So here this number has two parts. Now this is called the integral part. This is called the integral part. Integral part. And this is called the decimal part. Okay, so in this number we have two parts, the integral part and the decimal part. All right. Now the integral part is what we were dealing all the while. Okay, so how do you pair in the integral part from behind? So 1, 2 forms a pair, 7, 6 forms a pair, and 3 stands alone. But the decimal part, you should be pairing it forwards. Integral part, we pair it backwards. Decimal part, we pair the digits forwards. So 7, 9 forms a pair, 1, 3 forms a pair, 7 stands alone. But you can always add a 0. We know that we can add zeros to the extreme right or left of the decimal number. You cannot put a 0 like this in the middle. Then you're changing the value of the number. But to the extreme right or left, you can add how many ever zeros you want. You're not changing the value of the decimal number. You cannot insert a 0 between two digits in the number. Extreme right, extreme left, you can use zeros, right? So you can add a 0 here and make it a pair. 7, 0 forms a pair. So in the decimal part, you can always have, pairs of equal pairs. The integral part, if you have odd number of digits, one number will stand alone. In the integral part, if you have odd number of digits, one digit will stand alone. The first digit will stand alone. But in the decimal part, you can always add a 0 and make complete pairs. So what is this called? This is one number. This is one number. Okay, this is one decimal number. And if we have to find the square root of this number, how do you pair the digits? If you have to find the square root of this number, how do we pair the digits? So this part is called the integral part. I'm repeating. This is called the integral part. This is called the decimal part. Decimal part. Integral part, we pair backwards. Decimal part, we pair forwards. Okay, integral part now. 8, 7 forms a pair from behind. See, 7, 9 forms a pair. 1, 7 forms a pair. 1 stands alone. You cannot add 0 here and say, I made it 10. No, because you will change the value of the number given there. It's still, if you put 0 here, it's still 1 only. No, you can only use 1 ones are 1. It doesn't change the situation. You can add 0, but it's the same as not adding 0. Now in the decimal part, how do you pair? 8, 3, 4, 7, 6, 1, 3 alone. You can add a 0 and make a pair, 3, 0. There will be situations where we'll add 2 zeros and make a pair, 2 zeros, make a pair. We'll, encounter these situations with, a different type of question later. Okay. Not for a big number like this. I'm saying, supposing you'll have to find the square root of 2. Is this clear, children? Here you don't have to do this. Here you don't have to do this. Is this pairing part understood? Integral part backwards. Decimal part forwards. Now, later we'll learn how to find the square root of an imperfect square, say like 5. Find the square root of 5. 5 is not a perfect square because 2 into 2 is 4. 3 into 3 is 9. So 5 is not a perfect square. Now, if you so the question will be find the square root of 5 using the long division method. Find the square root of 5 using the long division method. That case, what you have to do is 5 means what? 5.000000. Now, supposing they say find the square root of 5 up to 2 decimal places, then you should have 3 pairs of zeros. The question will be find the square root of 5 correct to 2 decimal places. If you're asked, see, 5 is not a perfect square. So the question will be find the square root of 5 correct to 2 decimal places or 3 decimal places or 4 decimal places, whatever. So if the question is find up to 2 decimal places, you must have 3 pairs of zeros after the decimal point. One more, like 2 decimal places, 2 plus 1, 3 pairs. So this is the integral part. So there's only one digit, so 5. In the decimal part, 0, 0, 0, 0, 0, 0. 2 decimal places, so we have made 3 pairs of zeros. Okay. So this will be seeing ahead. Yeah. Now, how to find the square root of the given number using the long division method, 75.69. Integral part like this, decimal part like this, meaning I'll just use the arrow, right? Backwards like this we pair. This one forwards like this. So 75. 8 8s are 64, 9 9s are 81. So 8 8s are 64. 11 is a remainder. Now, you'll have to bring the next pair down, right? Next pair which comes down, but there's a decimal point here. So place a decimal point here and then bring the next pair down. You understand? This pair which comes down is after the decimal point. So place the decimal point in the quotient and then bring that next pair down. Now again double the quotient. 64. Oh, sorry. 8 to the 16. 16. Now, whatever digit you place here, you must place the same digit here. And this is the last step. And the number ends with the digit 9. So, 7 or? 7 or 3 or 7, because 3 3s are 9, 7 7s are 49. So you must try 3 or 7. Okay. Yeah, 3. When you use 3, it will be very small. 163 into 3. Yeah. It will be way less than this number. So we'll try 167 into 7. 7 7 the 49, 9 4 carried over. 42, 46, 6 4 carried over. So not much of a difference. You just have to place the decimal point. That's all. No other difference. When you're bringing a pair which is after the decimal point, when you're bringing a pair which is after the decimal point, you must place the decimal point in the quotient and then bring that pair down. That's all is the difference. Nothing else. The rest of the procedure is the same. Now, now here the division has come to an end. Supposing the division continues and you have to double the quotient. The quotient is 87. Don't see the quotient as 8.7. Supposing the division continues, okay? So in the next step, what you have to do, you'll have to double the quotient, right? Now, what do you see in the quotient? 8.7. See the number without the decimal point. 87 it is. So double 87. 87 into 2, you must do. 87 into 2. 14, 1 carried over. 174. And you should write 174 here. The division, this is over. I'm saying if we had to continue, this question cannot be continued. This is over. I'm saying in a situation where you have to continue and you have to double the quotient. The quotient is 8.7. So see the number without the decimal point. So 87, double it, 174. And that's what you should write here. And then as always, whatever digit you place here, place the same digit here. Complete this. The next one is a test. The next one you'll have to do by yourself. Let's see who can finish it correctly. Yeah, the next one. Yeah, now you have to practice. Yes. Yeah, please take the help of the slide and finish this one. The next question is a test. Don't try to do this by yourself. Please practice this one and the next one you can do by yourself. Well, next one, both the methods. Yeah, you can write 3 square. Correct. Instead of 3 into 3, you can write 3 square, 29 square, 2 square, and 5 square. Right.
Ma'am,
Yes.
ma'am, can you show the next question?
Okay. No, no. We'll just take down the question and we'll come back to that. Done?
Okay, ma'am.
Yeah. The next number is 2.0736. You're finished? 2.0736. Yeah, try the next one. Yeah.
And two decimal points means two zeros. So four, two decimal points means two zeros, and the number of decimal points is equal to number of zeros.
Correct, correct. Yeah. The number of decimal places,
Yes.
not decimal point. Yeah. So this number in B has 4 decimal places. So yeah, 4 zeros, 1 followed by 4 zeros. Yes.
Even though another number of this,
Yes, 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 yes. No, another number, meaning you can't use 4, you have to use prime factors only. No, I said I start with 2, only if it's not divisible by 2. See, supposing the number has prime factors 2, 3, and 5, and I normally do it in the order. I first try 2, and then 3, and then 5. Like, so I don't do it like first 5, and then 2, and then 3. Yeah, that's what I said. But that order is not important. You will still get the correct answer. What is important is you should use only prime numbers. You cannot use 4, 6, 8 and numbers like that. Composite numbers you should not use. Yeah. Found the square root using the prime factorization method. Got to finish. Srijit, found the square root of the number using prime factorization method.
Yes.
Yeah, send a picture of your answer on WhatsApp.
Finished the long division method, ma'am.
You finished the prime factorization method?
No, ma'am. I finished it only long division method, ma'am.
Oh, okay. Okay, send the picture of that one on WhatsApp.
Okay, ma'am.
Yeah, disable your mic, Srijit. What's your status, Navneet? Okay, for the numerator, you finished? Read out the prime factors you have. Now tell me in the exponential form, like this number is equal to 2 to the power 4 into 3 to the power 6. Tell me like that. How many 2's you have? Very good. Correct. Correct. What is 10? 2 into 5, right? See here, it's very easy. See, what is 10? 2 into 5. Listen, all of you. What is 100? 10 into 10, right? And what is 1000? 10 into 10 into 10. So 10 is 2 into 5. For this 10, you will get another 2 and 5. For this 10, another 2 and 5. So see, 10 is 2 into 5. 100 is 2 into 2 into 5 into 5. 1000 will be 2 into 2 into 2 into 5 into 5 into 5. What is 10? 2 into 5. 100 will be, what is 100? 10 into 10. So you will get another set of 2 and 5, right? Are you getting me? 10 is 2 into 5. What is 100? 10 into 10. 10 has 1, 2 and 1, 5. 100 is what? 10 into 10. So 100 will be 2 into 2 into 5 into 5. What about 1000? 2 into 2 into 2 into 5 into 5 into 5. Why? Because see here, 2 5s are 10, 2 5s are 10, 2 5s are 10. 100 is what? 2 5s are 10, 2 5s are 10, 10 10s are 100. So when you're doing the prime factorization for 1000 to 500 times, you'll get 2 3 times. So 2 250 times, 2 125 times. Then you'll have to use 5. 3 times you'll get 5. 5 25 times, 5 5s are 5 1s are. Huh? No, I'm just telling you, this is 10,000, is it? Yeah, so then you'll get 4 2s and 4 5s. Yeah. I'm telling you this because you should not take a long time to do the prime factorization for 10, 100, 1000 and so on. Rafa? Yeah, this is the earlier answer. For the steps. Yeah, that's why I presented it. Yes, you can. Sorry? Pass your book. No, after this, you should take square root on both the sides. You can take help of this answer. If you multiply, you'll get back this number. When you find the product, you'll get back this number. Correct? When you find the product, you'll get back this number. When you find this product, you'll get back this number. We're not supposed to do that. You'll have to write the step again and take square root on both the sides. Repeat the step and take square root on both the sides. So how many 2's are here? 8 2's. So 4 2's will come out of the square root. Then here, how many 4's? I'm sorry, how many 3's? 4 3's. So 2 3's out of the square root. Half the number of The prime factors will come out. Yes.
Power 2 and 2 to the power.
Correct.
Then we should multiply.
Then you should multiply.
No.
Finished.
Ma'am, like 2.0736 1 and then I subtracted and then got 1 and 2496 and then 1136, but the number is too low. Because 14 into 15.
1 second. What have you done? What is it here? 14. No, how did you get 196? 28.
Ma'am,
No.
14 is 14.
14 into 2.
Oh my God.
Perfect. It's time, so I have to present the answer. So you can complete with the help of this slide. So Srijit, the long division is perfect. Srijit, very good. Yeah. The wire மட்டும் தொட்டுறாத. இந்த பக்கம் வந்துரு. Come this side. Come good. Use the exponential form. So you will save time.
Yes.
See my working. 2 to the power 8. Suppose there are 22s.
At that time,
So 2 to the power 20. The exponential form is used to save time. And also you will not miss out on the factors. By mistake 8 2s or 7 2s pota, then
the answer will be.
Yeah. Correct. Very good.
Sorry for the tone.
Very good. You have to still try the long division method, is it?
Yes, ma'am.
Yeah.
The prime factor.
No. Sometimes you'll have only one prime factor happening so many times. As long as you can divide, you can keep using it. So there's another way of presenting the answers. You see here. Sometimes when the denominator is too large, like 10,000 or 1 followed by 6 zeros, you don't have to spend time finding the prime factorization of that number. See what I've written? 10,000 is 100 square. You can do that also. Only for 100, 10,000 and numbers like that. Okay. So 10,000 can be written as 100 square. So from 200s, 100 out. Yeah. Very good. Finish the long division method, Navneet? Yes. No, I think we have a different no, it's different. So 2.0736 is 20736 divided by 1 followed by 4 zeros. 1, 2, 3, 4 zeros. Right? So this the fraction equivalent of this decimal number is this one. Yeah. So now find the prime factorization of the numerator. You can see it here. Denominator I have not found. 10,000 is 100 square. So I've used 100 square. You can present it like this also, because when the number is too large and you can easily write it as a perfect square like this, you can prefer this one. You can save time there. Okay, so this decimal number can be expressed like this as a fraction. That's the first step. Then you see the prime factorization of the numerator here. So this number is equal to, the numerator can be expressed like this, 2 to the power 8 into 3 to the power 4. 1, 2, 3, 4, 5, 6, 7, 8. 2 to the power 8 into 1, 2, 3, 4. 3 to the power 4. The numerator 20,736 is equal to 2 to the power 8 into 3 to the power 4. The denominator 10,000 can be written as 100 square. 100 into 100 is 10,000. Correct? Yeah. No, because when you take square in the next step, okay, listen to me. So next step, what you'll have to repeat the step and take square root on both the sides, correct? Next step is repeat the step and take square root on both the sides, correct? Now what's the next step? Now this one, this fraction is nothing but this. Put the question back. This fraction is nothing but this one. Put the question back, okay? So square root of 2.0736 is equal to, now this is 2 to the power 8. Okay, so half of it will come out of the square root. So power is 8. Half of 8 is 4. So 2 to the power 4 out of the square root. The power is 8. Half of that is 4. So 2 to the power 4 will come out of the square root. Then here what's the power? 4. Half of that is 2. So 3 square will come out of the square root. Correct? And here what do you have? 100 square. So like 100 into 100, there are 200. So 100 will come out of the square root. 100 into 100. 100 square is 100 into 100. There are 200s. 100 will come out of the square root. Correct? So we write it as 100 square. 100 square. So 200, that is 100 out of the square root. Okay. So now find the product. 2 to the power 4 is 16 and 3 square is 9. And 16 into 9 is 144. 2 to the power 4 is 2 into 2, 4. 4 2s are 8. 8 2s are 16. 3 square is 9. 3 into 3, 9. So 16 into 9. 16 into 9 is 144. 144 by 100. 144 by 100 is 1.44. Because the given number is a decimal number, its square root also should be expressed as a decimal number. The given number is a decimal number. So the square root of this number should also be expressed as a decimal number, which is 1.44. Now the long division method. Long division method. 2.0736. How do you pair it? Two 2.0736. Yeah, like this, correct? Yeah, yeah. 1 ones are 1. 1 is the remainder. This one has to come down, but it's after the decimal point. So place the decimal point and then bring 0.7 down. Double the quotient. 1 into 2, 2. Whatever you place here, place the same digit here. 4, 4. 24 into 4. 96. Subtract. 11. 7 plus 4, 11. Yeah. Bring the next pair down.
26.
Double the quotient. What's the quotient? 1.4. Don't see it as 1.4. See it as 14. See it without the decimal point. The quotient is 1.4, but see it without the decimal point. So 14. Double it. 28, not 196. Not 14 into 14. 14 into 2. Always into 2. Quotient is always into 2. 28. Whatever you place here, you must place the same digit here. And this is the last step. And it ends with 6. 6 6 are 36. 4 4s are 16. 4 into 4 is 16. You will get a 6 in the end. Or 6 6 are 36. You will get a 6 in the end. So you'll have to try 4 and 6. Which one works? Yeah, 6 is great. When you use 6, it will be greater than this number. Okay, so it is 284. 284 into 4. 284 into 4 is 1136. So the square root of the given number, therefore, square root of 2.0736 is equal to 1.44. All right. Very good. So this I'll just tell you the procedure. You can try this as homework. Find the square root of 7. Correct up to 2 decimal places. Yeah. So 7 is not a perfect square. 2 into 2, 4. 3 into 3, 9. So 7 lies between the perfect squares 4 and 9. 4 is a perfect square. 9 is a perfect square. 7 lies between 4 and 9. It's not a perfect square. That's why the question is find the square root of 7. Correct up to 2 decimal places. So approximately up to 2 decimal places. Okay. So place 7 like this. And since you need to find up to 2 decimal places, see 7 point have 3 pairs. 1, 2, 3. 3 pairs of zeros after the decimal point. You should have a decimal point because 7 is 7 point. You can add how many ever zeros you want. 7 is also equal to 7 point, and you can add how many ever zeros you want. But we use 6 zeros because we want 3 pairs, right? One more than 2 decimal places. So one more than this. So 3 pairs. Now you should do the division as always. So you will do it. Okay. Now supposing you get, or maybe we'll just do this in the class. The next few sums I'll give us homework. Finish this in the class now. Do the division. Yes, Navneet.
Ma'am, the answer is 2.51.
2.51. No, dear. 2 point, you're correct till there. 5-1, the digits are incorrect. No. 5 is incorrect. 6 is correct. No, 6-2 is incorrect. No. Do it again, Navneet. It's 2.6, not 5. Do it again. You didn't try 6, is it? That's wrong. You should always make sure that the next number is greater. Yeah. You need to get one more digit. Correct. Six, 4. Yeah, continue. One more digit you have to get. Yeah, that's all, no? Because we have only 3 pairs. So for every pair, you'll get one digit. Children, you're taking a long time. You got, show me your book, come here. First recording பார்க்கலையா? அப்ப கஷ்டமா தான்டா இருக்கும். நீங்க you see you have time. Monday அடுத்த கிளாஸ்க்குள்ள நிறைய டைம் இருக்கும். ஒன்றும் ப்ராப்ளம் இல்லை. ஃபர்ஸ்ட் ரெக்கார்டிங் பார்த்துருங்க. ஏன்னா ஃபர்ஸ்ட் ரெக்கார்டிங்ல எதெல்லாம் கற்றுட்டோம் நம்ம, அதனால உங்களுக்கு இருக்கு. Okay, so all this we learned in the first session itself. So don't worry. Now you can just do it along with me. Please watch the recording. I shared it. No?
I thought it was linked to the online class. My mother told like that.
இல்லையா அந்த thumbnail இருந்துக்குமே. One second. Sorry, I'll do it now today. I'll share both today. Okay, so watch it before you come to the next class. Okay. Yeah. Correct. 2.645 is correct. Okay. So it's 2 2s are 4. I'll do check your numbers. 2 2s are 4. 3 is a remainder. The next pair comes down, but that's after the decimal point. So we'll have to place the decimal point here in the quotient. Double the quotient, 4. Whatever digit you place here, place the same digit here. So it's going to be 6. 6 6 are 36, 3 carried over. 6 4s are 24, 27. The remainder is 24, correct? The next pair comes down. Double the quotient. Double the quotient, so it's going to be 52. Whatever you place here, place the same digit here. Correct? Yeah, now what is it? 5 to 4. 5 to 4 into 4. 2096. What's the remainder?
30.
304. Then the last pair of zeros come down. Double the quotient. What's the quotient? 2.64. But don't see it as 2.64. Look at it as 264. Double it into 2. What is it? 5 to 8. And what's the last digit? 5. 5 to 8, 5. 5 to 8. Whatever digit you place here, place the same digit here. And it's 5. 2, 6. 4 to 5. And what's the remainder? 3000. See if it's right. Correct. No, it's not a perfect square, no. So you cannot get remainder 0 here. The division will go on and on. Yeah, okay. Now you learned it. The division will go on and on. The division will not come to an end. That's why the question says up to 2 decimal places. Yeah, I'll explain that. So square root of 7 is equal to 2.645. The square root of 7 is equal to 2.645, right? But they want you to write it up to 2 decimal places. Now, what's the last digit? 2.645. What's the last digit? 5. If it's 5 or if it's more than 5, you should take away this digit and increase this one by 1. See, if it was 2.648, then take away this digit and increase this one by 1. Why? Because if this digit is more than 5, then take away this digit and increase the earlier digit by 1. So it will be 4 plus 1, 5, 6.2, 2.65. But here, the last digit is 5. So simply remove it. If it's more than, yeah. No. You're not adding 1 to the integral part. To the decimal part, you're adding 1. Yeah. This you will never get 0 as a remainder. The division will go on and on forever. Yeah. See, I want to repeat this. If the quotient were 2.64, say 8. Now this digit, if it is more than 5, you must take it away and increase the earlier digit by 1. So it will be 2.65. Okay, suppose if the quotient was this, then you must say 2.65. But what's the quotient here? 2.645. It's not more than, if it is more than 5, it should increase by 1. If it is 5 or less than 5, simply take it away. Simply take it away. If it's 5 or less than 5, simply remove the last digit. If it's more than 5, remove the last digit and add 1 to the earlier digit. So when should you add 1? If the last digit is more than 5. If the last digit is 5 or less than 5, simply remove it. That's how we round off. That's how we round off. So it's 2.64, correct to 2 decimal places. If the last digit is more than 5, take it away and increase the earlier digit by 1. That is, add 1 to the earlier digit, add 1. If the last digit is 5 or less than 5, if it is 5 or less than 5, simply remove the last digit. Yeah, try this one. The number has a decimal point. You should find the square root up to 2 decimal places.
Ma'am?
Yes?
Ma'am, it's like some. We should put in a long division method.
Yes, yes. This can be done if it is an imperfect square. If the question is like this, correct up to 2 decimal places, it can be worked only using the long division method. You cannot work this using the prime factorization method. Children, you're not listening. The square root of an imperfect square cannot be found using the prime factorization method. Now this number, see, how do you know it's an imperfect square? That's why the question is find it up to, correct up to 2 decimal places. If the question is like this, that the given number is not a perfect square. Find the square root of 135.9, correct up to 2 decimal places. Why do you have this part in the question, correct up to 2 decimal places? Because it's not a perfect square. And if it's not a perfect square, you cannot find using the prime factorization method. You have to use the long division method, even if it is not mentioned. They have not asked you to use a long division method, but you have to use a long division method because it's not a perfect square. And also, you can see the last part of the question, up to 2 decimal places. So all this says long division method. So the number is 135.9. How do you group the integral part? Backwards, right? So 3, 5, and 1 stands alone. And the decimal part, 2 decimal places. So you need 3 pairs. 2 decimal places, so 3 pairs. So 9, 0. 1 pair, 0, 0. Second pair, 0, 0. Third pair. Understood this one? Understood this part, children? Yeah. 10 you got. See, what is the integral part? 135. 10 into 10 is 100. 11 into 11 is 121. 12 into 12 is 144. Now 135 lies between 11 square 121 and 12 square 144. Here is 135. So clearly the square root of the given number will be 11 point something. Now please understand that. What is 11 squared? What is 11 into 11? 121. What is 12 into 12? 144. Now we'll see only the integral part. So what's the integral part of the number? 135. Now where is 135? It's between 121 and 144. It's more than 121 but less than 144. So clearly the square root of this number should be 11 point something. It cannot be 10 point and it cannot be 12 point something also because that will be more than 144. So it has to be 11 point something. No, 11.60 is incorrect.
11.6.
11.6, okay. I want 3 digits after that. Meaning I want 3 decimal places. 11.6 is correct. After that?
0.
No.
How, man?
How, ma'am? My calculator says. And எவ்வளவு pairs இருக்கு? After the decimal point, how many pairs you have? 3. So you should have 3 digits after the decimal point. You will get no. Every time you bring one pair down, you'll have to add a digit in the quotient. So you will have 3 digits, right? For every pair, you will be adding 1 digit. When you bring a pair down, you'll add a digit in the quotient, right? You will not get remainder 0. Remainder will not be 0. It's not a perfect square. That's why the question is correct up to 2 decimal places. What's the third digit? One more digit you need to get. Six five, right? Yes.
11.657. From 11.66. From 11.67. 657.
11.65. Let the others finish. Yeah, what's the remainder? Yeah, how far have you finished, Navneet? $1,400. 350? What part have you finished? 11 point? Okay, you're finding the last digit, is it? Seven to 9:15. 7 to 9:15. Okay, it's time, so I have to show the answer. Correct. What's the number you have at that stage, Navneet? Correct, correct. Oh, very fine. Very good. Yeah, actually, yes. Yeah, please check your numbers. Yeah, please complete it. Please check your numbers. The decimal point here. So now see here, it's 11 point. Listen to this, 657, right? Now the last digit is more than 5. So take it away and increase the earlier digit by 1. So it will be 66.11, 11.66. This is how you round off. All right? Check your numbers at every stage. Check the quotient and all these numbers 1, 0, 3, 5, 2, 1, 1, 4, 9, 0. Check these numbers. And check these numbers also. Check if you've got 121, 226. Check all these numbers. Don't see only the remainder. Don't see this final answer and then this final thing and say, oh, yeah, I got it right. No. Check the numbers you've got at every stage. Yeah, we have 20 more minutes. 21, correct. 54. Finished? Online children? You need to ask. Okay.
Done, ma'am.
Okay. Wait, another 15 minutes. Wait. Sit away from the AC. Find the square root of 81 by the repeated, the next side, find the square root of 81 by the repeated subtraction method. Okay. So 81 is a perfect square. And what is the square root of 81? 9. So we know it's 9. Now we'll see this method, how to find the square root using the repeated subtraction method. Okay. Now here, in this method, we'll be making use of the odd numbers. We'll be making use of odd numbers. All right. Now write this number 81 minus 1. See the odd numbers 1, 3, 5, 7, 9, 11, 13, 15, 17. So first, the given number is 81. 81 minus 1, 80. Now write 80 and take the next odd number 3. 80 minus 3, 77. Now 77 here. Next odd number 5. 77 minus 5, 72. 72. The next odd number is 7. 72 minus 7, 65. 65 minus the next odd number 9, 56. 56 minus after 9 is 11, right? Odd numbers. After 9 is 11. So 56 minus 11, 45. 45 minus after 11 is 13. 45 minus 13, 32. 32. After 13 is 15. 17. 32 minus 15 is 17. And 17. After 15, the next odd number is 17. 17 minus 17, 0. So you should continue this procedure till you get the remainder or the difference as 0. Till you get the difference as 0. You will get 0. If the number is a perfect square, you will get 0. The difference will be 0. At a point, the difference will be 0. If the number is not a perfect square, then you will not have this, you will not be given this question like find the square root using the repeated subtraction method. This question is applicable only for a perfect square. Yeah, the number of steps. I haven't finished. Here. So this is the procedure. Now, how do you find the square root of 81 in this procedure? How many steps have we used here? 1, 2, 3, 4, 5, 6, 7, 8, 9 steps. So the square root of 81 is 9. So the square root of 81 is 9. All right. Now let's take 25. Let's take 25. 25 minus 1 first. Want a handkerchief? (21) minus 1, the first odd number 1, 24. 24 minus 3, after 1 is 3, so 21. Now 21 minus the next odd number 5, 16. 16 minus the next odd number 7. How much? 9. 9 minus after 7 the next odd number is 9. 0. So how many steps? 1, 2, 3, 4, 5. Therefore, the square root of 25 is 5. Understood, Navneet? Yeah. They'll not ask you to find using this method. Nice question. They'll not ask you to find the square root of a very large number using this method. That's it. Yeah, that's it. Okay. Uh-huh. No. You'll not be given a question like this under this method. Take down. Find the square root. Please write down, children. Find the square root of 81 by the repeated subtraction method. Number of steps is 9. Therefore, the square root of 81 is 9. Done, children? Online children, finish writing this one?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Yeah, take down this question. Yeah, okay. Find the find the smallest square number exactly divisible by 12, 15, and 24. See, we have come across this question. Find the smallest number. We have come across this question as early as in standard 4. Find the smallest number exactly divisible by 12, 15, and 24. And that will be the LCM of these three numbers. LCM. Okay, if the question is find the smallest number exactly divisible by 12, 15, and 24, then the answer is the LCM of these three numbers. But here the question is find the smallest square number. So it is not enough if you find the LCM. So you should find the LCM here, but it is not enough if you find the LCM. That number should be a perfect square also. That smallest number should also be a perfect square. So you must find which is the smallest number exactly divisible by these three. LCM. If the LCM is a perfect square, that's the answer. But if the LCM is not a perfect square, then that's not the answer. You should find the closest to perfect square. And that's the required number. So we'll see how to do that. I just want you to understand the question. If you have to find the smallest number, it is the LCM. But here you'll have to find the smallest square number. So we'll see how to find the smallest square number. So for that, you'll have to first find the LCM of these three numbers. Okay, so that you know how to do. LCM you know how to find. So the LCM of these three numbers is 2 square into 2 into 3 into 5. Now, in a square number, every prime factor will occur in pairs if the number is a square number. Now see here, in this number, 2 this prime factor 2 does not occur in pairs. 3 also does not occur in pairs. 5 does not occur in pairs. So for 2, 3, and 5 to happen in pairs, there should be one more 2, one more 3, one more 5. There should be one more 2, one more 3, and one more 5. So the required smallest square number exactly divisible by 12, 15, 24 is equal to, write the LCM, that is 2 square into 2 into 3 into 5. And since this does not occur in pair, multiply by a 2 so that it becomes 2 square. This also does not occur in pair. So multiply by 3 and here multiply by 5. So in the next step, it becomes 2 square as it is. 2 into 2, 2 square. 3 into 3, 3 square. 5 into 5, 5 square. Now you see every prime factor occurs in pairs. So now this number will be a square number and this will be the smallest square number. So the answer is 3600. Let's understand the answer. So 3600 is exactly divisible by 12. See, let me tell you this first. What is 2 square into 2? 4 2s are 8. 8 into 15, 120. The LCM is 120, children. The LCM is 120. But we know 120 is not a perfect square. Find the smallest square number, meaning the number should be a perfect square. The LCM of these three numbers is 120. But 120 is not a perfect square. Okay, so see, 120 is exactly divisible by 12. 120 is exactly divisible by 15. 120 is exactly divisible by 24. The LCM of these three numbers is 120 and the LCM 120 is divisible, exactly divisible by 12, 15 and 24. But that's not the required number because it's not a square number. 120 is not a square number. 11 into 11, 121, 12 into 12, 144. It's not a square number. So you'll have to find the smallest number, and that smallest number should be a square number also. So for that, you'll have to make every factor occur in pairs by multiplying suitably. So you need to have one more 2. In this product, you need to have one more 2, one more 3, and one more 5. So then it becomes 2 square into 2 square into 3 square into 5 square. And this product is 3,600. Now, 3,600 is the smallest square number. It's a square number. What's the square root of 36? Quickly. What's the square root of 36? Sorry, what is it? Yeah, what is the square root of 36? 6. And how many zeros here? 2 zeros. So 1 0 in the 60. So the square root of 3,600 is 60. So this is a square number. 3,600 is a square number. 3,600, the square root of 3,600 is 60 because square root of 36 is 6 and 2 zeros, so I have only 1 0 here. Half the number of zeros. Okay. So see here children, 3,600 is exactly divisible by 12. 3,600 is exactly divisible by 15. When you divide, it will be exactly divisible. And 3,600 will be exactly divisible by 24. So this is the smallest square number exactly divisible by 12, 15 and 24. Right on?
This is the smallest one.
Yeah, this is the smallest square number for these three numbers. Right on, children? Yeah.
Yes.
Yeah. Finish, Navneet?
Done, ma'am.
Very good. Yeah. See, LCM part I did not explain. You must help yourself here. This is the procedure to find the LCM of these three numbers. So this I did not explain. I assume you know it. You have not forgotten. All right. All right. Okay. Yeah. Is 6,000 a perfect square? Give reasons. Is 6,000 a perfect square? Give reasons. Now, a number which ends with odd number of zeros cannot be a perfect square. A number that ends with odd number of zeros cannot be a perfect square. Ten is not a perfect square. 10 is not a perfect square. 100 is a perfect square. A number that ends with odd number of zeros cannot be a perfect square. So it's not a perfect square, we know. It's not a perfect square. But how do you, justify? Is 6,000 a perfect square? Give reasons. 600 is not a... Every number that ends with even number of zeros need not be a perfect square. May or may not be a perfect square. Now 400 has 400 ends with 2 zeros, even number of zeros. It is a perfect square. But 500 also ends with 2 zeros. But 500 is not a perfect square. Yeah, may or may not be. Yeah. If a number ends with even number of zeros, it may or may not be a perfect square. But if a number ends with odd number of zeros, 1 0, 3 zeros, 5 zeros, it cannot be a perfect square. So how do you justify that? By working. It's like this. So, okay. So perform the prime factorization part like this. This you know. Okay. So what is 6,000 equal to? 6,000 is equal to 2 1 second, sorry. 6,000 is equal to 2 square into 2 square into 3 into 5 square into 5. Correct? Here, 6,000 is equal to 2 square into 2 square into 3 into 5 square into 5. Correct? Now you can see that this prime 3 and 5 don't occur in pairs. That's why it's not a perfect square. Because if the number is a perfect square, every prime factor will occur in pairs. You can see this 3 and 5, they don't occur in pairs. That's why 6,000 is not a perfect square. Two marks, you'll have to show working like this. 2 or 3 marks question, you'll have to show the working like this. Okay, so see the reason. Since 6,000 cannot be expressed, since 6,000 cannot be expressed as a product of pairs of equal prime factors, it's not a perfect square. You need to focus to understand this. What is this here? It's a product, right? It's a product here, correct? We are expressing 6,000 as a product. Yes or no? We are trying to express 6,000 as a product here in this equation. Okay. And product of pairs of equal prime factors. 6,000, you're not able to express it as a product of pairs of equal prime factors. Prime factors, we understand? Equal prime factors. Equal primes meaning, see now, 2 into 3 is also a pair. 2 into 3 is also a pair. But they're not equal primes. They are prime. See, it's a pair, but they're not equal primes. It should be 2 into 2, equal primes. This is a pair of equal primes. 2 into 3 is a pair of primes, but not a pair of equal primes. What is 2 into 3? It's a pair of prime factors. It is a pair of prime factors. But it's not a pair of equal prime factors. But what about 2 into 2? It is a pair of prime factors. It's a pair of equal prime factors. So you should be able to express, if it is a perfect square, you will be able to express the number as a product of pairs of equal prime factors. So here the reason is, since 6000 cannot be expressed as a product of pairs of equal prime factors, it is not a perfect square. Because see here, pairs, you don't have a pair. Here also no pair. You have 3 into 5. 3 into 5 is a pair, but it is not a pair of equal primes. So it's not a perfect square. This is the reason. Since 6000 cannot be expressed as a product of pairs of equal prime factors, it is not a perfect square. Or if you want to write it in simple words, you can say 6000 is not a perfect square because 3 and 5 do not occur in pairs. You can also give that reason. That is also accepted. Yeah, you can also give this reason. 6000 is not a perfect square because the prime factors, or you can say the primes 3 and 5 do not occur in pairs. Do not occur in pairs. You can also give this reason. Simple. In your own way. Meaning what? Without using, not in the same order you're saying. Yeah. Understood, children? Okay, finish this. Done working? Okay. Okay, since it's time, I'll just share this. No, you complete it. You might forget it also. Complete it. Write the reason you see here and then say, or you can write this reason. Write the or reason also. I'm saying the alternate reason. You can even underline that in your answer. If you're finished, you can leave. Anirudh. Have you taken the or reason? The alternate reason I've given? I asked you to write down. No? See, whatever you see on the board, you must take it down in your book. You took only the alternate reason. I know that. You should write both. You learn one of it for the exam if you want. Yeah. Finish writing, online children?
No, ma'am.
Yes, ma'am.
Okay. All right, children. So that's it for today's session. Thank you so much. Online children, complete writing this one and you can leave the call. Good night.
Thank you, ma'am.
Yeah, thank you. Good night.
Thank you, ma'am. Good
Finish
night,
writing,
ma'am.
Srijit and Sahasra?
Yes,
Yes,
ma'am.
ma'am.
Okay, children. Thank you.
Thank you, ma'am.
Good night.
Good night, ma'am.